You ever just stop and look up at a giant skyscraper, a real monster of steel and glass, and think to yourself, how in the world is that thing standing on what's basically just dirt? Right? It feels like it should be impossible. Well, the answer isn't up in the clouds, it's this incredible secret hidden deep, deep underground.
See, what we notice is the amazing part that reaches for the sky, but that's really only half the story. Underneath all that, there's a whole other world, an equally massive and complicated foundation system. It's almost like an upside-down skyscraper, anchoring the whole thing to the planet.
And that really is the big question, isn't it? With all those tons and tons of weight pushing down, day in and day out, what kind of engineering magic stops these giants from just sinking into the ground? Well, the answer doesn't start with pouring concrete. It actually starts with a little bit of detective work.
That's right. Before a single steel beam goes up, engineers have to become expert soil detectives. Their very first job is to figure out exactly what kind of ground they're dealing with. Because let me tell you, not all dirt is created equal.
This whole process has an official name, site exploration. Think of it as a full-blown investigation of the crime scene, or, the construction site. The entire goal is to gather every single clue about the soil so they can design a foundation that's not just safe and strong, but also makes financial sense.
What they're really doing is reading the land's geological story. They're digging in, analyzing rock formations, layers of soil, where the water is, all to build this complete profile of the site's biggest strengths and, more importantly, its weaknesses.
And they have a very specific checklist they're going through. First up, how strong is the soil? They call this its safe bearing capacity. Basically, what's the absolute maximum pressure the ground can handle before it just gives up? They also need to know how much the building is going to settle over time, because they all do, a little bit, where the water is underground, and try to predict any problems they might run into. Getting all of these answers right is absolutely critical.
So, once all that detective work is done, and it turns out the soil at the surface is just, too weak, engineers know they can't build on top of it. They have to go deep. And this calls for a very specific kind of solution.
It's called a deep foundation. And the idea behind it is actually pretty simple. If the soil on top is no good, you just bypass it. You build a foundation that's incredibly deep compared to how wide it is, kind of like a set of super strong stilts, to transfer all that weight from the building way, way down to a much stronger layer of soil or even solid rock. So yeah, you absolutely need a deep foundation when that surface soil just can't take the heat, and the building would otherwise sink too much. And for these huge structures like skyscrapers, the most common, most important type is something called a pile foundation.
All right, so let's talk about these piles. You can think of them as the true hidden pillars holding up our modern skylines. But it's not as simple as just one part. It's a whole system working together.
Yeah, this isn't just a bunch of posts stuck in the ground, no way. It's a highly engineered system, with different parts all working in perfect harmony to get that building's massive load safely down into the earth. Okay, so it all starts with the column. This is the part of the skyscraper we actually see. It collects all the weight from every floor above it and channels that force straight down toward the ground.
But that column doesn't just sit on the piles. No, it rests on this thing called the pile cap. Think of it like a giant, super thick concrete hub that acts as a distributor. It takes all that focused weight from the column, and it spreads that load out perfectly and evenly across a whole group of piles underneath it. These are the real legs of the skyscraper, the things that finally transfer all that weight safely into the ground.
But how exactly do these legs even work? It's not always as simple as just setting them on top of something solid. It turns out there are two main ways these piles handle such an unbelievable amount of weight.
Okay, so the two methods are called friction piles and end-bearing piles. A friction pile works because of the grip of the soil all along its sides. A great analogy is trying to pull a nail out of a piece of wood. It's the friction holding it in. An end-bearing pile, on the other hand, just gets drilled all the way down through the soft stuff until it hits solid bedrock, and it literally just rests on top of it, like a stilt on a concrete floor.
There are also two main ways to actually get these piles in the ground. You've got precast piles, which are made in a factory, trucked to the site, and then just hammered into the earth. The other way is cast-in-situ, which literally means cast in place. For that, you drill a hole, pull all the soil out, and then pour concrete directly into the hole to make the pile right there.
And here you can really see the difference in action. Over on the left, you've got this powerful machine just driving a pre-made pile right into the ground. And on the right, you can see the cast-in-situ method, boring a deep hole to build the pile from scratch. Two totally different ways to get to the same result, a rock-solid foundation.
So now, let's go back to our building one last time. When you look at it now, you're not just seeing the part that's up in the air, you're seeing the invisible part too. The dozens, maybe hundreds of piles reaching deep into the earth that make the whole thing possible. Suddenly, the ground's big secret isn't such a secret anymore.
It really makes you wonder, doesn't it? If this unbelievable system is holding up our tallest buildings, what other invisible engineering marvels are out there, quietly supporting the world all around us every single day?